Good morning. Today, I'd like to discuss some hot questions based on functions. These type of questions are very important because your previous year CBSE questions in the last 5 years, there must be one question is compulsory from this section. Is it a 6-mark question or a 4-mark question? So these are very important, and try to do 2 or 3 times for understanding the concept. Okay, let's start the video. Our next question: a function f from r plus 2, a function f from r plus 2 for infinity. A function f from r plus 2 for infinity defined by f of x is equal to x square plus 4, f of x equal to x square plus 4. Show that f is invertible. Hence find f inverse. If a function is to be invertible, that means that function is 1 and 1, 2. And to be bijective function or one-on correspondence, another term is invertible function. A function is to be bijective, then that means function is invertible. A function is one-on corresponding, that means function is invertible. And a function is to be invertible, that means we have to prove that, we have to show that our function is 1 and 1, 2. This function is already set as a domain and range. That is, already this function is set as a domain and a range in the function is 1 and 1, 2 shape. Okay. First of all, we prove that our function is 1, 1. It is 1, 1. First of all, we have to prove that our function is 1, 1. You already know the condition f of x1 is equal to f of x2. That implies x1 square plus 4 is equal to x2 square plus 4. And therefore, 4 cancel, x1 square is equal to x2 square. Or x1 square minus x2 square is equal to 0. In factorization, we get answer x1 plus x2 into x1 minus x2 is equal to 0. You know, here x1 and x2 are positive real number. Their sum is not equal to 0. Therefore, the only possibility is x1 minus x2 is equal to 0, because the product of two functions is 0. The first time is not equal to 0, and therefore second time is 0, and therefore x is equal to, we get answer x2, and therefore our function is 1, 1. Our function is 1, 1. That's all. Now the second case, we have to prove that our function is 1, 2. Next we have to prove that our function is 1, 2. We take a letter y is equal to x square plus 4. We take y is equal to our function x square plus 4. From this we find x. That is x square plus 4 is equal to y. And therefore x square is equal to y minus 4. From this x is equal to, we take a plus or minus value, but our domain is a set of all positive real numbers. So we consider only positive value. That is root of y minus 4. Now we find f of x, that is f of root of y minus 4, that is root of y minus 4 the whole square. When we put x is equal to root of y minus 4, we get root of y minus 4 the whole square, that is y minus 4 plus 4, and plus 4, y minus 4 plus 4, that is we get answer y. That is for each y element of 4 infinity, there exists a pre-image. Here what is a pre-image? Root of y minus 4 element of r plus, and therefore f is 1, 2. That means our function is 1, 1 and 1, 2. Therefore our function is invertible. Our function is invertible. Since f is invertible, there exists an inverse function. That means we form a function f from r plus to 4 infinity. Since the function is bijective or invertible, we form a inverse function from second set to first set. Okay, because function is 1 and 1, 2, that means we form an inverse function. Here the inverse function is f inverse x is equal to, here the inverse function is, we get x equal to root of y minus 4, we replace y by x, that is root of x minus 4, that is the inverse function, that's all. Okay. അപ്പോൾ ഒരു ഫംഗ്ഷൻ 1 on 2 അവർ ബൈജക്റ്റീവ് ആവുന്ന കേസ് മാത്രമേ നമ്മൾ ഇൻവെർട്ടബിൾ ഫംഗ്ഷൻ എന്ന് പറയൂ. ഒരു ഫംഗ്ഷൻ ഇൻവെർട്ടബിൾ ആയി കഴിഞ്ഞാൽ ദെയർ മസ്റ്റ് ബി എൻ ഇൻവേഴ്സ് ഫംഗ്ഷൻ. ഒരു ഫംഗ്ഷൻ r പ്ലസ് ടു 4 ഇൻഫിനിറ്റി ക്രിയേറ്റ് ചെയ്യുന്ന പോലെ തിരിച്ചും നമുക്കൊരു ഫംഗ്ഷൻ ക്രിയേറ്റ് ചെയ്യാൻ പറ്റും 4 ഇൻഫിനിറ്റി ടു r പ്ലസിലോട്ട്. ആ ഫംഗ്ഷൻ ഇവിടെ നമ്മൾ ഫോം ചെയ്യാൻ പറ്റും. മറ്റൊന്നും ചെയ്യേണ്ട, എക്സ് ഇസ് ഈക്വൽ ടു റൂട്ട് ഓഫ് വൈ മൈനസ് 4 ഫോം ചെയ്ത് കഴിയുമ്പോൾ വൈ റീപ്ലേസ് ചെയ്ത് എക്സ് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്ത് കഴിയുമ്പോൾ വി ഗെറ്റ് ഇൻവേഴ്സ് ഫംഗ്ഷൻ. 1 on 2 ആവുന്ന കേസുകളിൽ മാത്രമേ ഇൻവേഴ്സ് എക്സിസ്റ്റ് ചെയ്യുള്ളൂ, ഇൻവേഴ്സ് ഫോം ചെയ്യാനും പറ്റൂ. ഇപ്പോൾ സപ്പോസ് ഏതെങ്കിലും ഒന്ന് കോൺട്രാഡിക്റ്റ് ചെയ്ത് 1 on 2 കോൺട്രാഡിക്റ്റ് ചെയ്ത് കഴിഞ്ഞാൽ ഫംഗ്ഷൻ ഈസ് നോട്ട് ഇൻവെർട്ടബിൾ ആൻഡ് there does not exist inverse function. Okay. Now discuss one more question. It's a very important type question. Is try to practice 3 or 4 times is very important. Next question is a function f from r plus 2 minus 5 infinity, r plus 2 minus 5 infinity, close interval minus 5 infinity, defined by f of x is equal to 9x square plus 6x minus 5. 9x square plus 6x minus 5. Show that f is invertible. Show that f is invertible. Hence find its inverse function. Hence find its inverse function. Okay. Now start the class. First of all, we have to prove that our function is 1 on. You already know, if suppose f is said to be invertible, then we have to show that our function is 1 on and 1 2. First of all, we have to show that our function is 1 1. That means f of x1 is equal to f of x2 implies 9x1 square plus 6x1 minus 5 is equal to 9x2 square plus 6x2 minus 5. Here minus 5 cancel, and therefore 9x1 square minus 9x2 square plus 6x1 minus 6x2 is equal to 0. Take a right side term to the left side. Now here 9 is common, then x1 square minus x2 square can be written as x1 plus x2 into x1 minus x2. Here also 6 is common, we get x1 minus x2 is equal to 0. Here x1 minus x2 is common again. x1 minus x2 is a common factor. Into balance 9 into x1 plus x2 plus 6 equal to 0. Here you know the product of two terms is 0. Either first factor equal to 0 or second factor equal to 0. Here already know this term x1 and x2 are two positive real number. That means their sum is not equal to 0 because it's already a positive term. And therefore it equates first factor, that is x1 minus x2 is equal to 0. From this we get answer x1 is equal to x2. That means our function is 1 1. Our function is 1 1. Okay, now we prove the second part. Okay, first of all you take f of x1 equal to f of x2, that is 9x1 plus 6x1 minus 5 equal to 9x2 square plus 6x2 minus 5. Common cancel here, you take all the terms are right side to the left, then you take a common factor x1 minus x2, but here two terms on product is 0, either first factor equal to 0 or second factor equal to 0. Second factor is already not equal to 0 because it's already a positive quantity, because x1 and x2 are two positive real number. And therefore using first factor equal to 0, we get x1 is equal to x2. That means our function is 1 1. Okay. Next we prove that our function is on 2. That is our function is f from r plus 2 minus 5 to infinity, and the function is 9x square plus 6x minus 5. Okay. Next we show that given function is on 2. Okay. Okay. For proving 1 2, first we take a let y is equal to 9x square plus 6x minus 5. Next we find x using this function. There are different methods are available for finding x in quadratic formula. You know, complete square, we apply complete square method, or using quadratic formula, quadratic equation, using quadratic formula we find the value of x. There are three methods are available already. Here I use a simple technique for finding x. First of all, I convert this into a perfect square. I mean 9x square plus 6x minus 5 എന്നുള്ള ടേമിന് ഒരു ഹോൾ സ്ക്വയർ, ഐ മീൻ ഒരു പെർഫെക്റ്റ് സ്ക്വയർ ആയിട്ട് ഇതിനെ കൺവേർട്ട് ചെയ്യുന്നു. That means 9x square okay, 3x the whole square express here. 9x square is 3x the whole square plus 6x നമുക്ക് 2ab, that is a square plus perfect square means a plus b the whole square form convert. You know a plus b the whole square. What is a plus b the whole square? A square plus 2ab plus b square. This formula is converted. That is 9x square can be expressed as 3x the whole square. Then 2 into a correspond to here 3x. 2 into 3x into b. But 2 into 3x already we get 6x. So b is 1. But 2ab formula. Plus b square. B square b correspond to 1. 1 square that is 1. So more on add cancel and 1 minus c. Then we have already minus 5. So a square plus 2ab plus b square formula. So a correspond to 3x, so 2 into 3x. B correspond to 1 because 2 into 3x is already 6x. So b correspond to 1 6x form. So take b equal to 1. Then b square is 1 square, that is 1. So 1 add the cancel minus 1 add. Then write the constant minus 5. That is y is equal to, this is a simple method. Otherwise use quadratic formula we get x. It's very difficult to find. Here 3x square 2 into 3x into 1 plus b square, that is a square plus 2ab plus b square, that is 3x square plus 2 into 3x into 1 plus 1 can be written as 3x plus 1 the whole square plus, then balance minus 1 minus 5 is minus 6. That is y plus 6 equal to, we get answer 3x plus 1 the whole square. And therefore 3x plus 1 is equal to root value positive value, that is y plus 6 because r plus is a positive, and therefore 3x is equal to, we get answer root of y plus 6 minus 1, and x is equal to root of y plus 6 minus 1 divided by 3. Okay, now we find f of x. That is f of x means, here already you know f of x means 9x square plus 6x minus 5. Therefore f of x, here x correspond to root of y plus 6 minus 1 divided by 3 is equal to 9 into, you take a square value, that is root of y plus 6 minus 1 the whole square by 3 square is 9. Plus 6 into root of y plus 6 minus 1 divided by 3 minus 5. Here 9 cancel. Here 3 cancel, 2. Now expanding this term we get answer root of y plus 6 the whole square, a minus b whole square, that is root of y plus the whole square is y plus 6. Minus 2ab, 2 into root of y plus 6 into 1 plus b square, that is 1 square. Plus 2 into root of y plus 6 minus 2 minus 5. Here minus 2 root of y plus 6 cancel. 6 plus 1 7, minus 2 minus 5 7 cancel, and therefore we get answer y. Right, for each y element of minus 5 to infinity, for each y element of minus 5 to infinity, there exists a pre-image. There exists a pre-image. Here what is a pre-image? We get answer root of y plus 6, root of y plus 6 minus 1 divided by 5. There exists a pre-image root of y plus 6 minus 1 divided by 3. There exists a pre-image root of y plus 6 minus 1 by 3 element of the first set r plus. For second set, minus 5 to infinity, there element pre-image. Y is element corresponding pre-image. Suppose you take y is equal to 1, or suppose you take a 2, y equal to 2 in the minus 5 to infinity, then there is a pre-image is root of 2 plus 6. This root of 2 plus 6 means root 8 minus 1 by 3, which is an element of positive real number. That means for each y element of minus 5 to infinity, there is a pre-image in the domain R plus, and therefore f is onto, and therefore f is onto, therefore f is invertible, bijective or invertible. And therefore the f inverse y, here also we prove that f inverse y equal to square root of y plus 6 minus 1 divided by 3, and therefore f inverse y equal to root of y plus 6 minus 1 divided by 3. Okay. Now do one more question similar to this type of question. It's also very important questions. So try to practice this 2 or 3 times. Okay. A function f from n to s. Here s corresponds to the range of the function. Already they set the range and domain. That means this function is already 1 on and 1 to n. Now we have to show that this function is 1 on and 1 to. Okay, if from n to s defined by f of x is equal to 4x square plus 12x plus 15. 4x square plus 12x plus 15. 4x square plus 12x plus 15. Okay, we have to show that 4x square plus 12x plus 15. This function is 1 on and 1 to. I mean, if we have to show that this function is invertible, hence find this f inverse function. Okay. First of all, we find 1 on 1 case. Prove that 1 on 1. That is, f of x1 is equal to f of x2 implies 4x1 square plus 12x1 plus 15 is equal to 4x2 square plus 12x2 plus 15. Here, 4 into, take a right side term to left side, that is 4 into x1 square minus x2 square plus 12 into x1 minus x2 is equal to 0. Here 15 cancel. And therefore, here x1 minus x2 is common. Balance 4 into, because x1 square minus x2 square means x1 plus x2 into x1 minus x2. Balance term x1 plus x2 is balance plus 12 is equal to 0. You know, 4 into x1 plus x2 plus here x1 and x2 are set of all natural numbers is always positive. This term is already positive, which is not equal to 0, and therefore using 0 factorization theorem, either x1 minus x2 equal to 0, and therefore x1 is equal to x2, and therefore our function is 1 1. Our function is 1 1. Okay. Next we show that our function is onto. Okay, next we show that our function is onto. Our function is f from n to s defined by f of x is equal to 4x square plus 12x plus 15. 4x square plus 12x plus 15. Okay, now we prove that f is onto. How to prove? We take a y is equal to our function as 4x square plus 12x plus 15. First of all, we convert this quadratic equation into a perfect square. First of all, we convert this quadratic equation to a perfect square. Otherwise, we already there are different methods are available. Using quadratic formula, we find x, or complete square we can find x also. But this is a simple method to find x. You take a 2 or 3 or more steps, that's enough for finding x. Okay, let's start. Y is equal to, first 4x square means 2x the whole square, which is a square form. Plus 12x can be written as 2 into 12x, sorry 2x, 2ab. Then 2 into 2x, that is 4x. For getting 12, we multiply with 3. That is b correspond to 3. 2ab form. A correspond to x, b correspond to 3. Because 2 into 2x, we get answer 4x. For getting 12x, we multiply with 3. We get 12x. B correspond to 3. Then b square, that is 3 square, that is 9. Just to time add here, cancel here, 9 minus here. Then plus 15. That is equal to 2x square, 2 into 2x into 3 into plus 9. That is a square plus 2ab plus b square, that is, it can be written as 2x plus 3 the whole square. Expanding the term, we get this. Then minus 9 plus 15, we get answer 7. Minus 9 plus 15, we get answer 7. Sorry. Minus 9 plus 15, we get answer 6, sorry. Okay. That is y is equal to, we get answer 2x plus 3 the whole square plus 6. That is y minus 6 equal to 2x plus 3 the whole square. And therefore 2x plus 3 the whole square equal to y minus 6. That implies 2x plus 3 equal to root of y minus 6. 2x is equal to root of y minus 6 minus 3. And therefore x is equal to root of y minus 6 minus 3 divided by 2. X is equal to root of y minus 6 minus 3 divided by 2. Now we find f of x. F of x is equal to 4x square plus 12x plus 15. It is f of root of y minus 6 minus 3 divided by 2 is equal to 4 into root of y minus 6 minus 3 the whole square divided by 4 plus 12 into root of y minus 6 minus 3 divided by 2 plus 15 is equal to, here 4 cancel, here 2 12 cancel 6. Now expand the rooting using a minus b the whole square. Root of y minus 6 the whole square is y minus 6. Minus 2ab, 2 into root of y minus 6 into 3, that is minus 6 into root of y minus 6. Plus 3 square is 9. Plus, now multiplying with the 6, 6 into root of y minus 6, 6 into minus 3, 18 plus 15. Here minus 6 y minus 6 minus plus 6 into root of y minus 6 cancel. Here minus 6 minus 18. Now adding this term we get answer 24. Minus 24 and 15 plus 9 is also plus 24. Here this cancel this term and finally we get answer y. That is f of root of y minus 6 minus 3 divided by 2, we get answer y. Okay. Now write the last sentence. F from n to s and f of x is equal to 4x square plus 12x plus 15. Okay. Let y element of s, there exists a pre-image. There exists a pre-image. Here what is the pre-image? Here what is the pre-image? Root of y minus 6. Root of y minus 6 minus 3 divided by 2. Element of n. And therefore f is onto. That means our function is invertible. Our function is invertible. And therefore the inverse exists. And therefore the inverse function, that means second set in the first set of the function create here. That is inverse function. Our inverse function f inverse y equal to square root of y minus 6 minus 3 divided by 2. F inverse y is equal to root of y minus 6 minus 3 divided by 2. Okay, that's all. Okay, I will give some 2 or 3 homework question. Try to practice this type of question 2 or 3 times because it's very important questions. If you have any doubt, please contact me through my WhatsApp number. That's all today's class. Okay, next class we will start a new chapter, that is inverse trigonometric function. That's all. Thank you.